Hey, what's up, people? All right, so here we are, back again. Set my timer to 68 minutes. There we go. Okay, so yesterday we determined that we're going to use a database instead of JSON slash pickle. Granted that it would work and everything, which I'm assuming that it will, but I'm not completely sure. Honestly, I haven't used SQL before. I did take a little bit of a course on SQL, but I never actually um, took I never like finished the course, and I've never worked with it previously, so this would be new to me. Okay, so we stopped here at line 353, and yeah, so we had the previous options. Uh, we were going to use JSON or Pickle, and we decided we're going to use a database as recommended by ChatGPT because that's what was recommended. And let me get a second opinion. Let's ask Claude here. So let's pull Claude up. Claude is supposed to be really clever. Claude is supposed to be really smart, even smarter than ChatGPT, because that's what was recommended. So let's ask Python 5 to 10 writes per second, save file system, online card game. Should I use pickle JSON or this? There we go. Let's see if this works. Card game. Should I use? There we go. All right, let's see what the answer is. Oh man, he already. He already did it, dude. Claude, look at this. Claude done wrote a whole damn 30 minutes worth of code in 5 seconds. Goddamn. Alright, let's see what we got here. Let me help you think through the database versus file storage decision for your card game with 5 to 10 writes per second. Pickle JSON approach would mean frequent file open close operations, risk of file corruption if multiple writes happen simultaneously, no built-in concurrency control, limited querying capabilities. The database would be more appropriate here because built for concurrent access. ACID properties prevent data corruption. Better performance for this write frequency. And easier to query and maintain data integrity. Let me show you a simple SQLite implementation. Thread safe operations, automatic connection management, JSON serialization. JSON serialization for flexible game state storage, basic error handling, indexes for faster queries, and methods for saving and retrieving game states. So this is using SQLite and JSON. Why are we using SQLite and JSON? SQLite is chosen because zero server setup. It's just a file. Whoops, did I just do? Okay. SQLite is chosen because zero server setup. It's just a file perfect for a game with moderate write loads. Built into Python, no extra dependencies. ACID compliant, good enough performance for 5 to 10 writes per second. Can handle concurrent reads well, though only one write at a time. JSON within SQLite because game state data is likely to be variable nested, card scores, player states, etc. Schema flexibility, you can change your game state structure without changing database schema. What does that mean exactly? You can change your game state structure without changing database schema. Human readable for debugging. Better than Pickle for security. Execute arbitrary code. Yeah, but we're not worried about it executing arbitrary code, actually. Yeah, we're not worried about that. Because we're not like receiving from it, you know, it's all like secure sends. We don't have like a random person making pickled sends that could pickle malicious code and then be received and run, you know, on accident by, you know, someone receiving that code. That's not how this works. So why are we using JSON though? However, if you're concerned about the zero errors, if you need better write concurrency, Smoother SQL better for concurrent writes. Good for document-based game states. If you want simpler storage, plain JSON files, read is great for in-memory game state with persistence. Okay. I want the most performant option. One, let's just write this out. One, I want the most performant option available. Two, I don't need to read very often at all. 99% of actions are writes. Three, I'm not concerned about concurrent writes because that's probably not needed. 4, not concerned about security since sender is always trusted. Reform your recommendations based on these. Alright, let's see what the what he's gonna say now. So this completely changed my recommendation. Given these requirements, high performance writes, rare reads, no doubt concurrent writes needed, trusted data source. Pickle is actually your best option because it's the fastest serialization in Python. It's 2 to 10 times faster than JSON. 0 data transformation needed. Much smaller file size than JSON, and perfect for trusted data since security isn't a concern. Okay, what we got going here? So they're just saying use pickle. Let's see. Handler equals game state handler. It's like ultra fast version. Handler save state. Game ID 123 state active cards buffered game state handler. I don't know what that means. Won't write until buffer is full. Buffered force save force write remaining buffer. I don't know what that means. I don't know. I mean, I know what a buffer is, but I don't know why we're using a buffer here. I don't want to go too deep into what they're suggesting. I do want to consider them though, because, you know, AI represents the like amalgamation of human output, you know? So it means something. So we have self, baser, string, game states. So this game state handler is a class. We have base directory equals path of base directory. I don't know what any of this is doing. What are we doing here? Current file touch. What is this? Save state ultra fast. State saved using pickle. With open self. Current file WB is F. Pickle dump. Game state. Yeah, we're not just worried about game state. So this is buffer game state handler. Buffer states and write in batches for even better performance. Now that I don't understand. Why does buffer increase performance? Write performance. Okay, and then so one is why does buffer increase write performance? And then number two is we're actually going to be saving a bunch of different data points, such as game state, score, card, score, card.x, card.y, display layer, received data, stored data, stored received data, stored sent data. What else are we gonna be? IDs, card to ID dict, player.hand, player.melds, player.playcards, etc. And probably doing about 5 to 20 writes, or let's say 5 to 10. 5 to 10 writes per second. Would it still be better to use pickle instead of let's get this. So the key optimizations was it pre-creates file to avoid creation overhead. Creates file to avoid creation overhead. Uses highest pickle protocol speed. Optional buffering for writes. File rotation to prevent growth. Okay, file rotation. Okay, I understand what that means now. That makes sense. It does. Like you don't want the file to go to a certain. So then you create a new file. Minimal error checking, since it is trusted. This should handle 5 to 10 writes a second easily. If you need even more performance, use the buffered tuned buffer size. Memory mapping the file. Could switch to binary format instead of pickle if you really need to optimize. What would switching to binary versus pickle entail? Okay, so let's go down and see what else. Okay, so why does buffer increase write performance? Buffer increasing performance. Each file write has overhead. System calls. Disk I/O. Writing 10 states in one operation. Oh, wait, so it's like batching. Okay, so you create a buffer so it does it less often, but it's a larger write each time. Is that, I understand this correctly? Okay, writing 10 states in one operation instead of 10 separate writes reduces overhead. Think of it like mailing letters. Sending 10 letters in one envelope is more efficient than mailing 10 separate envelopes. Given this new context, I'm actually changing my recommendation back to a database. Here's why. So given this new context, I'm actually, structure. You have multiple related data types that would benefit from proper schema organization. Partial updates. You're updating many different fields independently. With Pickle, you need to load the entire game, save, modify one small part, save the entire state back. Do this 5 to 10 times per second. State objects mean more data to serialize, deserialize on every run. State objects mean more data to serialize, deserialize on every write. Query needs. You need to query specific parts of this data occasionally. Show you a more appropriate database structure. So okay, yeah, so it changed its idea, it changed its recommendation after I my requirements a little further. Back to, I think, SQLite, and it's saying the key advantages of this approach are partial updates. Update only what's changed, just a card's position, right? And I mean, that's going to happen a lot when we're moving the cards. So, like, that's actually pretty important. Yeah, that's actually pretty important. So, then we have write optimization using WAL mode and adjusted sync settings for better write performance. Using WAL mode, I don't know what WAL mode is, and adjusted sync settings for better write performance. A data organization related data is properly structured. Queries indexed for common access patterns. Yeah, we're not really gonna need to query it so much. Like, I don't think we're gonna need to. Well, I'm not sure exactly. I don't know if a query just means like a retrieval, or if query just means like finding something, yeah, like index or whatever. Yeah, I guess when we overwrite something, we are gonna have to query it, if that's what that means. It would make sense if they reference the index term. Binary storage, network data stored as raw binary. And I'm just gonna be straight up. Claude gives more fleshed out but complicated answers than ChatGPT. ChatGPT gives you more like straight to the point, concise answers that are usually very good, but sometimes misses the mark, rarely. But Claude seems to kind of understand, like, it goes deeper. I don't really know how to describe it, but the way that it answers your what do you call it, prompts, not the best, I would say. Like, sometimes it kind of assumes a little more than it should, you know, as to where ChatGPT kind of doesn't seem to assume as much. And just as far as readability, Claude seems to be a little harder to. The wording is just, it's like more complicated English, you know? I don't really know how to describe it. Anyhow, so binary storage, network data is stored as raw binary, which is probably why it's so fast compared to Pickle. It's like one step away from binary, and then database is like actually binary, or is this just network data? Network data is stored. I don't know. We'll have to learn. Would you let me explain any part of this in more detail? Show specific usage samples. Okay. So let's see what it reformed its answer to. So we have importing SQLite 3. We from context lib import context manager. From typing import dict, any, list, and then tuple. So this is to use, what do they call it? Type. Can't remember the word. Type something. Which lots of language require you to assign type for like any data point, any data structure at the time of assignment or creation, but Python doesn't require that, but you can use type hinting. That's what it is. Type hinting to basically implement that feature into Python. So we have card game DB, okay. So it makes a class, and let's see, initializes the database with optimized schema. So with self dot underscore get connection as con. Okay, so it does self init db. I'm confused though. What is this like? Init db doing? Like this class isn't inheriting from anything, so I'm just confused as to what that accomplishes. Okay, it's just a function we defined here. Gotcha. So then we say with self underscore get connection is con. Connection execute, create table if not exist, game states, game ID, current state, display layer, integer. So the game ID is the primary key, and it's a text string. Current state is going to be string. Display layer is going to be integer. Last updated is going to be timestamp default. Well, that's cool. It's got that built-in feature. It's a timestamp. That's pretty cool. Okay. And then con execute. Create table if not exist cards. Okay, so it's organized into different tables here. So game states has got the game ID, the current state, but this is incorrectly. Well, yeah, we would want the display layer to be with cards. So the card table has card ID, and that's going to be issue or text. It's going to be the primary key, and that's cool, I guess. Then we have game ID, which is going to be text, but that should actually be an integer. X is real. I don't know what that means. It's real. It's not fake. Sure. And then display layer integer. Okay, gotcha. Foreign key. ID references game states. Okay, so this foreign key thing, I remember learning about this in that course, I think, and this is basically connecting this table to this table, I think. Like, it allows me to access the data in this table, I think. It creates like a reference. That's why we have references, game states at game ID. So it will use that information to allow me to access the current state, the display layer, and last updated like very quickly. It will already like basically assume that I might be looking for that data next or something. I know that this foreign key thing connects them in some way. Okay, now we have con execute. So this is player data, moderate update frequency, frequent updates. So this is the creation of these tables. Create table if not exists. Players, player ID, text primary key, game ID, score, JSON array of card IDs. Melds, JSON array of meld data. And then play cards, text, JSON array of card IDs. Foreign key, game ID, references, game states, game ID. And then we have the network data. And this is the ID integer primary key auto increment. Game ID data type, received or sent. Data blob, store raw binary data. Okay, I don't know what this means. Why we would auto increment the ID? I guess this is like an event tracker for the network. Like, you know, network transfers and stuff. It's a storage. It's a way to store all of that. Okay. Yeah, so this is basically just like a little sample of how you could do this. On execute, create index if not exists, IDX cards game on cards, create index if not exists, players game, players game. Create indexes for frequent queries. So I guess this creating the index makes it perform better. I need to ask about that. This is something I might use. Concerning number 3, does that make the data retrieve faster or frequent? Then optional configure for better write performance. This is write ahead logging. Then pragma synchronous equals normal. Faster writes with reasonable safety. So I guess this removes a little bit of safety, but makes it write faster. So I wanted to explain this a little bit. Okay, so get connection. This is at context manager. I didn't know you could do that. So you could do at context manager to whenever you used in a context manager. Or okay, it just allows you to use this function in the context of a context manager. So you can say with self._ get connection. That's con. So you say con equals SQLite connect, and it takes in the database name, and then connection.row factory equals SQLite 3.row. Try yield con, and then con commit, finally con close. Okay. Yield, you don't see that very often. I've used that before, man. It's been so long since I saw that used. Dude, that's a... Man, it's been a hot minute since I've seen the yield keyword used. finally con close. So this is establishing the connection, creating a row, or a row factory rather, and then we do con commit, which I'm guessing is like establishing that connection or like committing to it. I don't really know what that means. I'll have to figure that out. And then what is dot commit? Okay. Context lib import context. And I'm guessing the context manager will ask me that as well. Guessing this allows the function to be called in the context of a context manager. What is a row factory? Okay, so it does this first. Okay, then I guess it yields. Does the yield allow all of the rest of this code to get run? And then it returns back here and does con commit and then does con close. Because I forgot what yield did, honestly, but I'm thinking yield is like, it's like return, but it doesn't actually return. It like pauses it, lets something else happen or whatever, and then comes back and returns later. Or it's like it's a return, but it comes back and finishes instead of terminating that function call at the point which is executed in case of return. Give connection as con. Yeah, because it yields the con and then we reference it as con, so I'm assuming that's what it does, and then it allows us to do con execute. So execute is going to be actually a method called on the SQLite 3. So that's a SQLite 3 method. So connect is the SQLite 3. Then we have that return as con, the like database object or whatever, called the connection, and then we're running the .execute on it, and then eventually we also would call con commit, which I'm guessing is a SQLite 3, and then con close, which be SQLite 3 as well. Okay, so then it updates the card position. We have self card ID string. So this is type hinting. This is establishing that the card ID will always be a string, or it has to be. Game ID has to be a string, or else it'll throw an error or whatever, or a warning at the very least. And then X is float, Y is float, here is int, and its default to none. Okay, with sub underscore connection is con if layer is not none. If layer is not none. To replace into cards. ID, game ID, XY, display layer, and then the values. Okay. I don't know why we have to have this right here. I guess I would have to understand execute a little better. Definitely we'll have to do that. Let's say 9. Explain how .execute works from start to finish. Okay. And this is updating the cards. Where does cards come from here? This. Insert or replace into cards. So cards is like a... Oh, so that's the table. The cards table. Right. Gotcha. So we're using execute to... So execute is basically just like take this action. Then we tell it what action to do based on this first line. In this case, it would insert or into the cards table, card ID, game ID, XY, display layer, and then the values for each are going to be what this question mark is, and then this is the actual data associated with each data point, and then we have this here. I don't understand why we have to have this. I guess this is like the variable name of the data structure in the file that we're copying to the database, and that this is the name associated with the field associated with that data point in the database, and the values would be whatever this equals. But I don't know why we wouldn't just like put this card, like card ID here, game ID here. I don't understand why. Why don't we I mean, I'll understand that as I learn the syntax more. So then we say else. So if layer is none, then we would update the cards set. X equals what, Y equals what, where E equals. We have X, Y, card ID. I don't know what this means, so I have to learn this syntax. This is new to me. Oh, I need some more coffee. Yeah, I definitely need more coffee. I think I'm gonna make another protein coffee. I took some caffeine, but it's not doing the trick. You know what I mean? Beat down. Yes, they put a real beat down on me today. So. Alright, so then we have update player, but I'm just getting a feel for it here. I'm looking at this, I'm seeing, I'm just getting a general feel for it, you know. Looking at someone else's work before I actually like try to learn just from scratch, I think that's pretty beneficial. Seeing completed work, giving it a once over, try to understand, you know, all the basics. update cards. I don't understand this at all. Update cards set X. So this means when layers is none. Okay, so it's gonna grab the card position. Basically, I think that's what this is doing. I'll get it to tell me exactly. What is that doing? What is this line doing? Alright, then we have update player hand, which takes self player ID string hand. This is not actually what it would be. It would actually be a list of integers, which were the card IDs. Player's hand with self-get connection is update players. So it's updating the player table, and it's setting the hand to it's a table, and I think it's called a field or something. Okay. Hand equals question mark where player ID equals question mark, and then you're basically passing hand to it, and then you're passing your ID. Okay. And I don't know why you have to write it like this. I guess that's just the syntax. Like you don't just write equals Jason dumps hand and then player ID equals player ID. You put a question mark and then you do it in this separate. I guess that's just the way it has to be done. Store network data with get connection as con. Execute insert into network data game ID. Data type data. And the values 3 question marks, and then these are going to be like the 3 that are passed into it. Yeah, so apparently this is the required syntax for whatever reason. Then we have bulk update cards, which takes self updates, which is going to be a list of tuples which consist of string, float, int. Okay, but I understand what's going on there though, I think. And it's an optimized bulk card update. So instead of just doing one at a time, with self get connection is con, execute many, update cards, set x equals wide where card, and then I don't know how that works. So we'll ask that as well. Okay, so this is going to be a massive prompt, and hopefully it will order these like one for one, and not just give me like some generalized answer that ChatGPT will some kind of like combine the questions and give me like this 2 answers for 11 questions. You know, I don't like that. I would rather like you just address them on a one basis. And I could probably dictate that in the prompt to ensure that it would respond to me in that way. If I like said, hey, don't do that. Tell me one-to-one. Questions one-to-one. So I could actually just say that. Say, please answer the questions one by one, not combining questions. So overall, I understand the general idea here, and this is going to be, you know, a similar implementation of which we're actually going to use. But let's go ahead and pass this prompt to it. Might be too big. Is it too much? I have to break it up. It's frozen. Okay, the computer's not frozen. The computer's not frozen. What's frozen? You telling me I wrote this shit for nothing? Now I can't use it? What's going on here? Claude is broken? Come on, dude. I literally wrote out all these questions. Please tell me I didn't write this for nothing. Fucking Claude, bro. What are we talking about here? Claude, dude. Come on, man. Oh, you bastard. You bastard. You made me write all this out? Is it just like lagging? Page unresponsive. Wait. Just let me copy this stuff that I wrote, man. Oh, man. Damn. So I'm gonna have to write it again? You gotta be shitting me, huh? That was actually a lot of work right there, bro. I don't want to have to redo this. That exit page is gonna... No way, huh? Oh, man. Well, you can't win every time, right? Now I gotta rewrite this shit. Oh, no. And I had some good... Are you kidding me, bro? That was like 5 to 10 minutes of analyzing and asking targeted questions. And it just got lost. Because Claude became unresponsive. Come on, dude. For real, though? I'm not gonna lie, that pissed me off pretty bad. There's no way I can restore this. Oh, it actually lost even more? Well, I don't want to use Claude now. I'm not gonna lie. This bad experience, this little thing, just made me not want to use Claude. That was actually, like, tough. I just lost all my text. There's no way to get it back. And the prompt and everything. So I gotta do this again. Disappointed in Claude right now. I'm actually saving various data points such as player hands, player minutes, player score, card X, card Y, card display layer, card ID. Yeah, bro, I'm mad. This really pissed me off. Gotta redo this again. Son of a bitch, man. I just did this, and I gotta write it out again. It's like 15 minutes of work just going. So maximum various data points each player hand, player melds, player score. Okay, we're doing 5 to 10 writes per second. Not worried about data security since sender/data is always trusted. It would be three would be most performant option for about reading. 99% of action are rights, and also not worry concurrency, as this will really not be required. I get triggered when things don't go. When things don't go my way. When things mess up that shouldn't mess up. I don't like wasting time. I really don't like losing time. Losing time makes me upset. I'm like kind of a productive person. I really hate to lose my time. Okay, let's see. So we have other specific fields and high write frequency. I recommend even simpler approach, directly picking individual attributes, periodically flushing to disk. So it's surprising. Like individual attributes to memory and periodically flushing to disk. Okay, but the purpose is to create a constant real-time save system that will restore the game state 100%, won't crash or desave. So we have to save the data externally from the local scripts / memory. So now I'm having to like get back to where we were. But wait a second, how do we have this without these, man? Okay, alright, I'm back. I understand what happened. Immediate external persistence. Maximum performance. Don't care about reads except during read concurrency. Trust the data. It's a file handle open for better performance. Uses OS fsync to force immediate disk writes. Reallocates file space to reduce fragmentation. Simple single file storage for easy recovery. It's complete state. Uses pickle. But wouldn't it be faster to use the database? / more reliable to use a database. See, I'm starting to feel like I should be using ChatGPT and not Claude right now. Requirements. 5 to 10 writes per second is actually quite low. Only writing trusty data, only writing to a single file, no concurrency, rarely reading, need crash recovery. I didn't overhead because connection management overhead, transaction overhead, schema management, query parsing planning, write ahead logging, additional process running. The approach is faster because direct file input output without a database layer, no query parsing, no transaction management, no connection overhead, simpler serialization. If you need concurrent access, if you need to query the data, if the write frequency increases significantly. Yes, I would like to see benchmarks because my concern here is that Pickle is going to load in the entire data dict each load. Okay, so we're at one message, so that was my last message. But I didn't really, well, whatever. Let me create a benchmark that specifically tests this concern. We'll compare full state pickle dumps, individual attribute pickle dumps, SQLite individual updates, and then SQLite batch updates. Okay, so this is a whole damn job it just created for me, is to look at this benchmark. Oh man, well, you know, maybe that's what we need to do. Maybe that's because all it is saying, just use pickle, and I think what it's saying is to use pickle in a way that will allow for individual attribute handling, as opposed to you have JSON, you have a JSON dictionary, you have to like redump the entire dictionary, you know what I mean? And you just modified one thing from it, and you're just doing that over and over again. You're dumping the entire huge data set, and only one little thing got changed, you know, because that's just the way you have to do it. As to where I think what it's recommending is to use pickle in such a way that you're only, instead of having like one pickled object that's the personified dictionary, you have like multiple pickled objects, one for each attribute. Does that make sense? But then, like, how do you query the data when you go to like read it? Like, how do you know what's what when you're dealing with it? because it's just data in the file. So how do you like know? I mean, you would have to like, you would have to put it in like a dictionary format and then pickle it, as I'm understanding, so that each pickled object is like a dictionary, and the key would be the attribute or data structure name, and the value would be the actual value. So it'd be like, let's say you change card 52's X value. At that point, you are going to create a dictionary, a Python dictionary that's called, just say card 52 as the key, and then it could be card 52.x would be the key, and then the value would be X value, because that's the only thing that got changed. So you only want to modify that specific data point, and then you would pickle it and write it to your save file. But you know, the question of that is like, how does it plan to reapply this data, and how does it plan to like overwrite old card 52x data so that when you reapply data, you are only applying the data that looks recent, you know, like, because it doesn't work like a JSON dictionary where you're overwriting, you know. It's, as far as I understand it, when you pickle it, it just becomes byte stream data. It's not in a human readable format, and it's also not in like a, it doesn't exist in a way that allows you to like query or index or access it via like a key. I mean, there is that feature, I remember, which turned pickle basically into like JSON. So this has become kind of complicated, honestly. All the like variations and ways that you can do it, there's a lot more, unless I'm just imagining things, but I'm pretty sure this is what it said. Let's see, let me go back up here and read. So it says, real-time persistence for crash recovery. Let's modify the approach. Since you need immediate external persistence, not just in memory, but we need to the hard disk, then you would do, and you would also need maximum write performance. You don't care about reads except during recovery. You don't need concurrency. You trust the data. It would have these features. You would keep the file handle open for better performance. Oh, I think I understand. Okay, so it's basically you're gonna have like a separate thread that always has that file open. You're not like reopening and closing it. You're just like, you always have it open in that one thread. You're constantly writing to it. Okay, that's actually cool. I didn't see, this is AI is good for this sort of thing, because I didn't really think I would be able to do something like that. I mean, I just wouldn't have thought. It might not mean, at least that gives me that idea. That's what I think it's suggesting. And then it says uses OS fsync to force immediate disk writes. I don't know what that means. Pre-allocates file space to reduce fragmentation. Pre-allocates file space to reduce fragmentation. But with pickling, we still have the risk of corruption, data corruption and stuff. Remember what ChatGPT said? ChatGPT said we're worried about that, or should be worried about that, and I actually do agree. I mean, obviously I want something that's going to be absolutely secure. And ChatGPT suggested that the database would still be faster. I don't really care if like Pickle is good if the database is faster and more secure. Even if it's like the same speed but more secure, I would just go with the database. That would be the deciding factor right there for me. Simple single file storage for easy recovery. Maintains complete state history. Uses Pickle for fast. So in this case, let me go right back up here because I think this is where it said. Let's see. Keeps everything in memory. Only serializes changed data. Right. So it says it only serializes the changed data, and it batches disk writes by time interval. We don't really need to worry about that, but that's cool. We're not worried about performance that much. Like, we don't need to do all that. I would rather constant persistency over making it a little bit more performant. You know what I mean? I want to make sure it's up to date rather than it happens a little bit faster. It's not going to impact the performance on that level. You have to find the balance between performance and persistency, and I would rather keep the safe state persistency maximized and the performance is secondary. So it uses default dict to avoid key checks. I don't know what that means. Uses Pickle's highest protocol. Pre-creates a file to avoid creation overhead and a minimal error checking. So in this case, see, so it would update the card position fast in memory. Okay, so this is keeping everything in memory. That's the problem. Yeah, that's silly. That's stupid. We couldn't use that because we need it to be outside of memory. We need real-time persistent for cache recovery, immediate external persistence, not just memory, maximum write performance, don't care about reads. Okay, right, I already read all this. So let's see, now it's saying to do each update is immediately persisted. So we have update card, update player, meld score, blah, blah, blah. After crash, recover from state. Single open file handle, no open close overhead. Minimal data transformation with Pickle. Reallocated file space, direct file operation, out, extra abstraction. No error checking or validation. Since it's trusted data, this should handle your... No state is also on crash. Would you like to... The database would add overhead. Okay, so it's saying that all this extra overhead of the connection management, the transaction, the schema management, the query parsing planning, the write ahead, I guess that's what WAL stands for, write ahead logging, additional process running. Oh, it's an additional process. Oh, okay, so the database itself is an additional process. Now, I don't think it would be that heavy to where the database would really mess anything up. But it says that the Pickle approach would be faster because it's direct file I/O without a database layer. So it's direct, but it's not as secure, almost certainly. No query parsing, however, if any of these change. Benchmark will show us, so let's see. Full state Pickle dumps, individual attribute Pickle dumps. Concerned about Pickle dumping the entire state is valid for the full state approach. The partial state approach I recommended earlier only Pickle's individual attributes, making it much more efficient. Would you like me to run this benchmark with different data sizes or patterns to simulate your specific use case more accurately, or shall I analyze these results? And if you'd like to see different data sizes, different write patterns, recovery time comparisons, memory usage profiles, and then specific failure scenarios. Okay, so our hour is up, but I actually want to see... Oh, I can't because I'm out of free messages. Ain't that a... So I would have to run this myself and get the benchmark, which is no big deal. Do this. I might actually do that. So what I need to figure out is the deciding factor right now for me is, okay, so if the database is more secure and is basically the same speed, I'm gonna go with the database. But if I find out we can use pickle in a way to pickle only the change data, I don't know exactly how that would work. I've used pickle and I'm familiar with pickle, but I don't understand how you can use pickle to get back, like, for one, I don't know when it says that we would just serialize each individual attribute. I guess what that means is it would serialize each individual attribute and then save it, like append it to the save file. Or is there a way to overwrite it, that specific data point entry in the save file? But I know since it's written in pickle, it doesn't work like that unless you were to use shelve or whatever. But I thought that we said that shelve wasn't a good option because, well, I think I chose JSON over shelve. Shelve is faster than JSON. Saving videos. I mean, use shelve. The big difference is that shelve can store almost any Python object. Right, but is it faster? Shelve can be faster than JSON, but depends on your specific use case. Shelve uses DBM, which is optimized for quick lookups and incremental writes, faster for frequent reads, writes of individual access. Okay, so it knows the context. Since you need 10 to 50 writes, Shelve is likely the better option. Okay, so we're gonna do this when we come back. I gotta go to the gym. I get some more coffee. Okay, but so now I'm considering pickle still, because if we could use pickle with shelve, or something like that. Because here's what I'm thinking, and this is gonna be my final thought, is what I'm imagining here with this pickle system. Well, if we didn't use a key value dictionary system wherein each saved attribute always overwrote the old value, I feel like that would be a nightmare if that didn't happen. I don't want to have to add in all this extra science to find which attributes have been applied and which didn't, and then once we get to a certain part in the save file, don't overwrite anymore. You know, that's just like crazy. I would not do that. So I think we have to have, I don't know the term for it, but we have to have direct, we'll call it direct data structure access. So write this down real quick, and then we'll down put things to do. Actually, I'll just put it right here. We'll say option number 3. Stop here. Do next save up line. Okay, so we're gonna say determine best option versus pickle slash shelve versus SQLite for 5 to 10 writes per second. No concurrency. 99% actions are writes, not reads. Data is trusted. Data is always trusted. No concurrency. 90% action. Alright, data is always trusted. What else? Need it to be saved externally, local script access or crash recovery save file. And then oh yeah, need direct attribute slash data point write slash overwriting to save file, not constant appends to save file. And what else is like our requirements? What other requirements do we have here? I think that's most of them. I just want to make sure I'm not missing it, so when I prompt it next, I'll have the most accurate answer. Name is extra rights. Oh yeah, also could keep the file constantly open instead of opening, closing. But like, doesn't that mean, and then also need to consider security of system such as file corruption slash data loss. Performance is very important, but secondary to constant data saves. Yeah, I think that's like basically it. So yeah, you got to make sure you get your prompt right. Prompt to AI to determine the best option. All right, so there we go. All right, so we're gonna go to the gym. I'm gonna go eat. Make me a protein shake because I'm feeling very, very, very tired right now. Continued prompting. Unfortunately, we didn't do any actual coding, but I mean, I would rather lay out the path that I'm actually gonna go down before just going down a certain path and then realizing, oh shit, well, we actually can't do this, or this way would have been so much better. I'd rather spend more time getting my choice right and then going with the correct option. So yeah, it's a learning experience. I'm learning all the differences between the databases, pickling, JSON, etc. I've learned a lot, so it's not really wasted time. I would say maybe 10% of it was wasted time, but that was mainly due to Claude messing up for whatever reason and making me lose my progress. But it's all good. It's no big deal. So anyway, we're going to figure this out. We'll come back, and I think I think we're gonna end up probably going with the database because I do want to learn that, unless it tells me that for whatever reason pickle would be sufficient. But because of the file corruption thing, I just don't see myself using pickle for that reason, because data is like secure with um, the database, and if it's basically just as fast. So and we'll say um, basically another prompt is, well, I guess it would consider all this stuff. Considering all of these requirements, would pickle slash shelve be faster than SQLite and just as persistent slash secure? Oh yeah, also consider the need to read and apply saved data efficiently and easily upon crash, i.e., I don't want to have to sort through a messy save file, a messy overloaded save file to determine which data is new slash old, etc. I would rather something that organizes and streamlines this process. Yeah, so I think when it takes all this in, it's going to be able to give me a really good answer. So then we'll put this last at the end of the prompt. And honestly, you know, just using like Stack Overflow or whatever, Google, and like going to read, man, honestly, that's so much worse. Using AI to prompt and get answers is just so much faster, and the quality is like most times better anyway, honestly. And just the like searching aspect that ChatGPT can do at the speed of light, which would, you know, it would research results in 5 seconds, which would take me like 5 hours probably to do the same exact thing. Anyway, so that's going to be our prompt. We're going to figure out exactly what we're going to go with. Probably going to end up being the database, I'm assuming. I think Claude was tripping. Maybe Claude's right though. Maybe Claude was onto something. We'll see. But I'm skeptical that this would actually continue prompting to determine best option for save file system. Yep, and that's it. All right, guys. So I'll see you. Yep, see you in a few hours. Peace.